The diagram shows a block of mass 4 kilograms resting on a rough horizontal table. It is attached to a ball m kilograms, so we've got this block here attached to this one here by a light inextensible string that passes over a smooth pulley, so there's no friction on the pulley at the edge of the table. The ball hangs vertically below the pulley. The coefficient of friction and the block is and the table is 0.4. The system is held in equilibrium by a force of 4√3 acting on the block at 30 degrees above the horizontal. The block is on the point of sliding towards the pulley. Calculate the frictional force acting on the block and calculate the value of m. Right, so before you attempt to do a problem like this, step number 1 is to draw a force diagram. So on the block we have a mass of 4g acting downwards, and we have the normal reaction acting upwards of the block with the table. As it's tending to move towards the pulley, even though it's in equilibrium, the frictional force will be here, so that's F is equal to mu r. It's on the point, so it's equal. We have a tension in the string here, and we have the same tension acting here, and then we have the weight of the mass m kilograms here. Okay, so first of all we've got to find the frictional force F, and then secondly we've got to find the value of this mass here. Okay, so for the 4 kilogram resolving vertically, so moving this way, we're going to have R. Okay, the system's in equilibrium, it's quite important, so we have R minus 4 R plus, now you've got to be careful here because we need this part here, which is also acting upwards, a force here, and that's going to be 4√3 sine 30, using your trigonometry, and then acting downwards is going to be 4g, so that one's negative, and it's equal to 0. So that gives that R is equal to 4g minus 4√3 sine 30. Sine 30 is a half, so we're just going to get 4g minus 2√3. Using F is equal to mu r, so we've got R and we know that mu is 0.4, so F will be equal to 0.4 times this, and that will give me 14.294. Make sure we keep the whole value because you will need that in a later calculation to avoid a rounding error. So that gives 14.3 newtons to 3 significant figures. Right. In order to find the mass here, if we now resolve horizontally for the 4 kilogram mass, we've got T minus 4√3 cos of 30 degrees, because we've got a force here acting that way, minus F is equal to 0 because it's on the point of slipping, but it's in equilibrium. So we're going to have T minus 6, because cos 30 is √3 over 2. 4 divided by 2 is 2, and then √3 times √3 is 3. 2 times 3 is 6. Minus 14.294. So that gives me that T will be 6 plus 14.294, which gives me 20.294, and that gives me, rounded off to 20.3 newtons. Again, keep that value because we're going to need it. Right, in order to find the mass, we're just going to resolve for this block now vertically. So resolve for the m kilogram mass. All right, because the tension here is the same, we're going to have, and downward is positive, mg minus t is equal to 0. Therefore, mg minus 20.294 will be equal to 0. And therefore, m will be 20.294, taking that there, and then dividing by g, which will give me a value of 2.0708, which is 2.0 kilograms, correct to 3 significant figures. So this has been a video to help show you how to find a missing mass using connected objects. I hope you've understood, and I thank you very much for watching.